Hello everyone, I am Professor Amit Thakur. Today we will discuss about this sorting algorithm, bubble sort operations and implementation in C. In this topic we are going to cover the following things: what is bubble sorting, working of bubble sorting algorithm, bubble sorting complexity, application of bubble sorting, where to use this bubble sorting, when to use, and last disadvantages of bubble sorting. The learning objective of this session is, by end of this chapter you will able to learn what is bubble sorting, working of this algorithm of bubble sorting complexity, and where and when to use this bubble sorting, and what are the advantages and disadvantages of bubble sorting. First of all, we will discuss what is bubble sorting. The bubble sort is a simple sorting algorithm that repeatedly steps through the list to be sorted, compares adjacent element and swaps them if they are in the wrong order. The process is repeated for every elements in the list until the entire list is sorted. Bubble sorts gets its name from the way the smaller elements bubble to the top of the list while larger elements sink to the bottom. Here are how the bubble sorting algorithm works. There are certain steps we need to follow. The first step is start. Begin by comparing the first two elements of the list. Second step is compare and swap. If the first element is greater than the second elements, then swap them. If they are already in the correct order, leave them as they are. The third step is advance. Move to the next pair of elements, that is the second and third elements, and the compare them. Repeat this process until you have compared and potentially swapped all adjacent elements in the list. The fourth step is one pass complete. After one pass through the list, the largest element will have bubbled up to the last position. The next step is repetition step. Repeat the process for the remaining elements excluding the last one that has already been sorted. The next step, that is step 6, is complete passes. After each pass, one more element will be sorted at its correct position from the end of the list. And at the last, there is termination. Repeat the process until no swaps are needed. This indicates the list is now fully sorted. The bubble sort has worst case and average case time complexity of order of n square, where n is the number of elements in the list. This makes it inefficient for large data set. However, its simplicity and ease of implementation makes it useful for educational purposes and for small data sets, where performance is not crucial. Despite its inefficiency, bubble sort has some advantages also. It is easy to understand and implement. Second, it requires only a constant amount of additional memory for swapping elements. It performs well on nearly sorted or small data sets. Algorithm. Now, we will talk about the algorithm. In this algorithm, the given below, supposed ARR is an array of n elements that assumes swap function in the algorithm will swap the values of given array elements. You can see I am here using a simple function like bubble sort, and in this function I have passed array elements, that is ARR. We will move this array loop for all the elements, for all array elements, and we will match if ARR of the first element is greater than of ARR of next element. So, this is basically we are passing the condition over here. If this condition is true, then we are apply the swap function. What swap function does? It simply swaps two numbers with each other, and after this will return the ARR, and this function ends. Working of bubble sort algorithm. Now, let us see the working of bubble sorting algorithm. To understand the working of bubble sort algorithm, let us take an unsorted array, because we are using to sort, we are here to sort the element of the array. So, we are going to take unsorted array. We are taking a sort and accurate array, like we as know the complexity of bubble sort is order of n. Let us take an example of array. Right now we have 5 elements in the array like 13, 32, 26, 35 and 10. This is unsorted array. In the first pass, the sorting bill starts from the initial 2 elements. Let us compare them to check whether which is greater. Now, we are going to compare the first 2 elements, that is 13 and 32. Here 32 is greater than 13. So, it is already sorted. So, now we don't need to compare this, don't need to sort, don't need to swap these two elements. Now again we will compare 32 with 26, the next two elements. Here 26 is smaller than the 36, so swapping is required because smaller elements after the greater element. So that is need to be swapped. After swapping, new array will look like 13, 26, 32, 35 and 10. Now we are going to compare next two elements, that is 32 and 35. Now you can see here 35 is greater than 32. So there is no swapping will be required. So either they are already, because they are already sorted. Now the comparison will be in between 35 and 10, that is last two elements. Here you can see array having like elements 13, 26, 32, 35 and 10. Now here 10 is smaller than 35, that are not sorted. So the swapping is required. Now we reach at the end of array, the first pass and the array will be like 13, 26, 32, 10 and 35. As you can see, the largest element has reached at the last of the array. Now this is the first pass we have already done. Now we can move to the second iteration. Now the second pass, the process is same as the first pass as we have already followed. Here we have array like 13, 26, 32, 10 and 35. Now we will compare first two elements 13 and 26. As you can see, 13 is smaller than the 26, so no need of swapping. After this we will take next two elements, that is 26 and 32. This again we do not need to require swap because 26 is smaller than the 32. After this we will move to the next two elements, that is 32 and 10. As we can see here 10 is smaller than the 32. So swapping is required. After swapping, the array will be like 13, 26, 10, 32 and 35. At the last we are trying to compare the last two elements, that is 32 and 35. So as you can see 32 is smaller than the 35. So no swapping is required. So our array will be like similar like 13, 26, 10, 32 and 35. Now this is end of pass of 2. So we can move to the next iteration, that is third iteration. Third pass, the same process will be followed for the third iteration. We have first two elements like 13 and 26, we do not need to require of swapping. So the array will be like this array remains same. After this 13, 26, 10, 32 and 35, we are going to compare two elements 26 and 10. As you know, these two elements, the 10 is smaller than the 26. So array will be required to swap two elements. Here as you can see, after swapping the array will be like 13, 10, 26, 32 and 35. Again we need to compare these two elements 26 and 32, though no need to swap because 26 is smaller than the 32. After this again last two elements will be compared, that is 32 and 35. So again no need to swap because 32 is more than the 35. So this is end of this third pass. So we will move to the next iteration, that is fourth iteration. The fourth pass, similarly after the fourth iteration the array will be like 13, 10, 13, 26, 32 and 35. Hence there is no swapping is required, so the array is completely sorted. Now we will talk about the complexity of bubble sort. Now let us see the time complexity of bubble sort in best case, average case and worst case. We will also see the space complexity of bubble sort. First of all, we will discuss about the complexity in three cases. In best cases, the complexity of order of n, the average case the order of n square, and the worst case is same as average case as is order of n square. Best case complexity, it occurs when there is a no sorting is required, that is array is already sorted. The best case time complexity of bubble sort is order of n. Average case complexity, it occurs when the array elements are in jumbled order and that is not properly in ascending order and not properly in descending order. So the average case complexity of bubble sort is order of n square. Worst case complexity, it occurs when the array elements are required to be sorted in reverse order. This means suppose you have to sort the array elements in ascending order, but its elements are in descending order. The worst case complexity of bubble sort is order of n square. Now we will talk about this space complexity. The space complexity of bubble sort is order of 1. It is because in bubble sort an extra variable is required for swapping, that is third variable. The space complexity of optimized bubble sort, that is order of 2. It is because the 2 extra variables are required in optimized bubble sort. Now, we will talk about the implementation of bubble sort in language C. Here I have included one header file, that is stdio.h header file with hash include preprocessed directive. Here I am using a simple a print function, and it is print function takes 2 arguments. The first argument is array and second argument simple integer variable. Here I am taking one variable, that is I, and I am running a loop from 0 to n minus 1. So, I am just printing the whatever inputs I have taken for the array. This function will treat as a printing for the array elements. Now, we will see this bubble sorting function, because I have taken one bubble function, and the types of this bubbles, return type of bubble function is void. In this I have taken already like 2 parameters. This first is array and second is number of elements. After this I have this defined 3 variables I, j and temporary. After I have taken one loop starts from 0 to n minus 1, and again inside this loop another loop, that is j loop, that is j starts from I plus 1, j less than n, I j plus plus. This is another loop inside I loop. Inside this loop I am simply comparing the element, that is if a of j less than a of I. This means that if the compares true, then I am going to swapping of these elements. Another element, that is a of I will be shifted to temporary variable, a of j will be shifted to a of I, and temporary variable again shifted to a of j. So, this code is basically for swapping of 2 numbers. After this I am just writing a main function. Inside main function I am writing this 3 more variables I, j and temporary variables. I have initialized an array list like a of 5, and values are 10, 35, 32, 13 and 26, and the size of, and another variable I have taken n, that is the value will be a size of a, that is 5 divided by the number of array elements of the first element, that is 2. So, this will calculate the number of elements present in this array. Before sorting I can print the array elements like print of a comma n. This will simply call the print function, and after this print function I am calling a bubble function, that is a comma n, and this will call bubble function. After sorting again I can call this print function. So, this will simply print before sorting array elements and after sorting the array elements. These are the output you can see on the screen. I have taken number of variables, and number of variables will be sorted after this bubble sorting. Bubble sort is simple sorting algorithm that has been around for a long time, and it becomes and its origins cannot be attributed to a single individual. The algorithm's basic concept of repeatedly comparing and swapping adjacent elements to sort a list is quite intuitive and has likely been independently conceived by multiple people over the time. Bubble sort is often taught as an introductory sorting algorithm, and its development can be attributed to broader computer science community over the years. It is not associated with a specific developer or inventor as some more advanced algorithm might be. Instead, it is a simple sorting technique that showcases the fundamental concept of element comparison and swapping. While the specific originator of bubble sort may not be known, the algorithm's simplicity and the basic principles have made it a part of early computer science education, helping students understand the concepts of sorting and algorithm analysis. Now we will discuss about the applications, various applications of bubble sorting. Bubble sort is one of the simplest sorting algorithms, but its inefficiency makes it less suitable for most practical applications, especially for larger data sets. However, bubble sort does not have a few limitations, use cases and educational purposes. First of all, we will see the educational purpose. Bubble sort is often used in educational setting to teach the basic concepts of sorting algorithm. It is straightforward to understand and implement, making it good starting point for student learning about sorting techniques and algorithm analysis. Second is small data set. Bubble sort can be used for sorting very small data sets where performance is not critical factor. Since its time complexity is order of n square, it can be reasonable to use for a like handful of elements. Next important point is teaching algorithm concepts. Bubbles sort helps in explaining concepts like iteration, elements comparison and swapping. It can be used to demonstrate the swapping between efficient and inefficient sorting algorithm. Next point is algorithm visualization. Bubble sorts, step by step comparison and swaps can be useful for illustrating the basic mechanics of sorting algorithm in visualization or tutorials. Practical jokes and puzzles. In non-serious context, the bubble sort has been used like humorously to confuse or challenge programmers due to its inefficiency. Puzzles might involve asking someone to sort a small list using bubble sort without revealing its inefficiency. It is important to note that for the most real world applications, other sorting algorithms like quick sort, merge sort and heap sort are preferred due to their significantly better average and worst case time complexity. These algorithms are more efficient and practical for sorting large data sets or in performance critical scenario. Where to use bubble sorting? Now, we can talk about where we can apply this bubble sorting. Bubble sorting is one of the simplest sorting algorithm and it is rarely used in practical applications due to its inefficiency, especially for larger data sets. However, there are few specific scenario where you might consider this bubble sort. The first thing where you can apply this bubble sort is small data sets for educational purposes. Bubble sort can be used in educational settings to teach beginner about sorting algorithms. It helps students to understand the basic concepts of elements comparison, swapping and algorithmic complexity. Demonstrating algorithm concepts. Bubble sort can be used to demonstrate how sorting algorithms work, helping individuals to grasp the basic idea of sorting and how elements are rearranged to achieve a order sequence. Programming interviews. In programming interviews, you might be asked to implement a simple algorithm. Bubble sort could be used in this context to assess your ability to implement the basic sorting logic. Next, where you can apply the bubble sort is sorting nearly sorted data. Bubble sort's this simple swapping mechanism can make it useful for scenarios where data is nearly sorted or where the elements are already in close to correct positions. Ad hoc scripting. For ad hoc scripting and small task where you need to sort a very small number of elements quickly and performance is not a concern, then bubble sort could be used. It is important to emphasize that while bubble sort has some specific context where it might be considered in most real world applications, there are more efficient sorting algorithms available such as quick sort, merge sort, heap sort, selection sort, insert sort and many more that offer significantly better performance. When dealing with its larger data sets or performance critical scenario, it is recommended to choose a more efficient sorting algorithm. Now, we will discuss about when to use bubble sorting algorithm. Bubble sorting is one of the simplest sorting algorithm, is rarely used in practical application due to its inefficiency, especially for larger data sets. However, there are few specific scenario where you might consider this using bubble sort. The first is educational purpose. Bubble sort is often used in educational settings to teach the students about sorting algorithms and sorting concepts. Its simplicity makes it a good starting point for beginners to understand sorting logic. Second is small data sets. Bubble sort can be considered where dealing with a very small data sets where performance is not a concern. Since its time complexity is order of n square, it can be relatively acceptable for a small number of elements. Debugging and testing. In case where you suspect issues with more complex sorting algorithm, you might use bubble sort to quickly verify where the sorting process is working as expected. This can be useful for debugging process. The next where you can apply this bubble sorting is learning algorithm logic. If you are new to programming an algorithm, implement the bubble sort and it can help to grasp the fundamental concept of elements comparison and swapping as well as introduce you to algorithm thinking. Specific constraints. In some specialized cases where the computational these resources are severely limited and the data sets is very small, bubble sort could be an option. It is important to understand that while bubble sort has this limited use cases, in practical scenario where bubble sorting efficiency is crucial, other sorting algorithms like quick sort, merge sort, heap sort and different sorting algorithms are more appropriate choices. These algorithms offer better performance and scalability for larger data sets. Now, we will talk about the applications of bubble sorting. While bubble sort is not widely used in practical applications due to its inefficiency for larger data sets, it is worth noting it that it can still be used in very specific situation where the data set is extremely small and efficiency is not a prime concern. Here are few scenario where bubble sort might find limited applications. First, the application is simple sorting demonstration. Bubble sort can be used in coding workshop, programming courses and tutorials to demonstrate the basic principles of sorting algorithm. It helps beginner understand how elements are compared and swapped to achieve a sorted order. Toy programs and learning projects. For small scale learning projects, coding challenges or experiments, bubble sorts can be implemented to practice coding skills and understand basic algorithmic concepts. Next is pre-sorted or nearly sorted data. If we have data sets that is already mostly sorted and has small number of out of order elements, bubble sort's behavior of swapping adjacent elements can make it suitable for making minor adjustment to achieve the complete sorting. Next application is sorting for very small data set. In scenarios where you have tiny number of elements to sort or less number of elements to sort and the performance is not a significant concern. So, bubble sorting can be used in this case as a simple and easy to implement solution. Next application is debugging or verification. If you suspect issues with more complex sorting algorithms, you might use bubble sort to quickly verify whether the sorting process works as intended. This can be useful for beginning purpose. Code interviews and challenges. In some programming interview scenarios, you might be asked to implement a sorting algorithm and bubble sort could be chosen to demonstrate your coding skills and understanding of basic algorithms. Now, we talk about the next application, that is historical or educational context. Bubble sort can be used to illustrate the concept of bubble sorting in educational material, computer science history discussions or introductory programming concepts or courses. It is important to reiterate the bubble sort time complexity of order of n square makes it inefficient for larger data sets, and there are much more efficient sorting algorithms available for most practical applications in professional software development and solution where performance matters. Algorithms like quick sort, merge sort and heap sorts are generally preferred choices. Now, we will talk about some disadvantages of bubble sorting. Bubble sort while have a simple and straightforward sorting algorithm has several significant disadvantages that limits its practical use, especially for larger data sets. The first disadvantage is inefficiency. Bubble sort has an average and worst case complexity of order of n square, where n is number of elements to be sorted. This makes it highly inefficient for sorting large data sets. As the number of elements increase, the time taken for bubble sorting grows quadratically, leading to the slow performance. The second disadvantage is slow on nearly sorted data. Bubble sort performance is not significant better on nearly sorted data. Even if only a few elements are out of place, bubble sort still performs a large number of unnecessary comparisons and swaps, that is leading to the suboptimal performance. Next disadvantage is number of swaps. Bubble sort requires a relatively large number of swaps to sort the elements. Swapping elements in array can be computationally expensive, especially in large language that requires copying or moving large chunks of memory. Next disadvantage is lack of adaptiveness. Bubble sort does not adapt to input data's properties, it simply performs the same number of comparisons and swaps regardless of whether the data is already partially sorted or not. Next disadvantage is no early exit. Bubble sort continues, it passes through the entire the list of array even if the list is already sorted before all iterations are completed. This adds unnecessary overhead. The next disadvantage is ineffective of larger data set. Due to its inefficiency, bubble sort is not practical for sorting larger data sets in most real world applications. There are much more this efficient sorting algorithm available for sorting the array. The next disadvantage is performance comparison. Bubble sort's performance is significantly worse compared to more efficient sorting algorithms like quick sort, merge sort and heap sort, which have average case time complexity of order of n of log of n, and they perform better than the better on larger data sets. Next disadvantage is not suitable for stable for default, like the basic version of bubble sort is not stable, meaning meaning that it may change the relatively order of equal elements. Additional steps are required to make it stable, which adds complexity. The next disadvantage is limited practical use. Bubble sort is mainly used for educational purposes, simple coding exercises and scenarios where performance is not a concern. In summary, bubble sort's inefficiency and lack of adaptiveness make it impractical for most real world example or real world applications, especially when they are dealing with the larger data sets. It is important to consider more efficient sorting algorithm for sorting tasks that require good performance and scalability. Now, I am going to conclude my session with, in conclusion, bubble sort is a simple and intuitive sorting algorithm that involves comparing and swapping adjacent elements to achieve a sorted order. While it serves as an effective tool for learning about basic sorting concepts and algorithm principles, its limitation make it unsuitable for most practical applications. So, bubble sort's quadratic time complexity of, that is order of n square, makes it highly inefficient for sorting larger data sets, or leading to slow performance as the number of elements increases in the array. It lacks adaptiveness, does not take advantage of existing order and requires a relatively larger number of swaps. These disadvantages render it impractical for real world scenarios that demand efficient sorting. While bubble sort's role in educational context, small scale projects is very important. The world of computer science offers more efficient and practical sorting algorithm. Algorithms like quick sort, merge sort and heap sort provide faster average case and worst case performance, making them better choice for sorting tasks in professional softwares development and other performance critical applications. In summary, while bubble sort showcase fundamental sorting concept, it is essential to explore and apply more efficient sorting algorithm when performance and scalability are vital. The understanding gained from this studying bubble sort can serve as a stepping stone to tackle more complex sorting algorithm and broader algorithmic challenges. One more thing I want to add with this session, like suppose we have bubble sorting to sort in ascending or descending order. While we swapping by comparing two elements, there are number of first we compare the smaller elements with the larger element. If it is so, then we do not swap the elements, and if the first element is greater than the next element, then we try to swap these two elements. Here the bubble sort simply sorts either in ascending order or descending order. Depending upon the requirement, we choose the less than sign or greater than sign. Suppose we are taking greater than sign, it will simply arrange the elements in ascending order. If we choose the less than sign, it will simply arrange the these elements in descending order. So, depending upon this requirement, we choose the bubble sorting this algorithm. First of all, before starting this bubble sort, I must emphasize on the concept of array. Because this bubble sort requires the logic or something that is to be implemented on the array. So, array is a basic part to implement this bubble sorting. So, first of all, you know what is array, when to use this array, 2D or a 3D array, something like. First of all, we know what is array. The array is a concept where we need to take the similar elements into the array and we can arrange number of elements. So, as I said earlier in this session, this array, this bubble sorting is not suitable for larger elements, larger data sets. So, for larger data set we can move to the next different algorithms for sorting, but for smaller elements of array we can simply use this bubble sorting, because it is very easy to understand and very easy to implement the code. In C, as we have seen, The code simply tells if the elements are in proper order, we do not swap. If the elements are not in proper order, we try to swap the values. So, in this case I must suggest this bubble sorting is this sorting algorithm is very for basic learning sorting algorithm for a beginner. And if you know, if you have basic concept, basic understanding of different concepts of array and different things, and if you have time complexity and this performance is very crucial, then you can move for the different sorting algorithms. I revised my session by saying the few words like a sorting algorithm is used to rearrange a given array or list of elements according to the comparison operator on the elements. The comparison operator is used to decide the new order of elements in the respective data structure. We have number of sorting algorithms. I want to take some few sorting algorithm name like selection sort, bubble sort, insertion sort, merge sort, quick sort, heap sort, counting sort, radix sort, bucket sort, bingo sort algorithm, shell sort algorithm, team sort, com sort, pigeonhole sort algorithm, cycle sort, cocktail sort, strand sort, bitonic sort like pancake sorting, BOGO sort of or permutation sort, genome sort, sleep sort. This sleep sort also known as the king of laziness. Structure sorting in algorithm, there are number of C++ sorting algorithm, std sort, tag sort, tree sort, odd even sort, that is also known as a brick sort, three-way merge sort. So, these are the list of sorting algorithms, various sorting algorithms. Sorting is an arrangement of data in a particular order, but if we talk about sorting in data structure, then it is more relevant to rearrange the data or element in ascending or descending order, which can be like lexicographical, numerical, or maybe user defined. For example, consider you have 5 siblings and you want to arrange them according the height. Now, if you wish to arrange them in increasing or decreasing order of height, then algorithm you will perform to do this task, that is sorting. But more interestingly, in how much time you can do it. Suppose if you do it in 5 seconds, then your brother is given a chance that he does in 3 seconds, then his idea would be best among of you. That is the complexity of your algorithm. Sorting is the process of arranging items in a specific order or sequence. It is a common algorithm problem in computer science, and it is used in various applications such as searching, data analysis, information retrieval. In other words, you can say that the sorting is also used to represent data in more readable format. Some real life examples of sorting are like contact list in a mobile phone, that is also contains all contacts arranged alphabetically. And so if you look for contact, then you do not have to look randomly, and you can search easily and many others like apps on your phone. Second, keywords in your book also in a lexicographical manner, and you can find it according to your chapter. So, these are some examples of this sorting algorithm. With this I conclude my session. Thank you all.